Morning. Today we will discuss about the UV visible spectroscopy, which lies under the range of electromagnetic spectrum from 10 nanometer to 800 nanometer wavelength, and the complete waveguide, which lies between 400 to 780 nanometer, is comes in visible regions. And UV visible region basically contains two type of regions: near UV and far UV. Near UV lies between 200 nanometer to 400 nanometer, and far is studied under vacuum lies 200 below 200 nanometer. Generally, ethyl alcohol and hexane is used as a solvent to study any sample in it. And this spectroscopy is predicted or studied under the discussion of different electronic transitions. Basically, these are six types: sigma, sigma star, pi, pi star, and pi star, and sigma star, sigma pi star, pi sigma star. This transition is based on the transition of an electron from ground state to antibody state or excited state at different frequency ranges or wavelength ranges. Like sigma sigma transition, when sigma electron from orbital is excited to corresponding antibody sigma pi sigma star, the energy for this purpose is very high, because saturated system comes under this type of transition, and the absorption maxima is 125 nanometer. Pi pi transition, when pi electron in a bonding orbital is excited to corresponding antibody orbital pi star, and it is generally, we all know that pi electron and pi bond is present in multiple or unsaturated bonds like alkenes, alkynes, carbonyl, nitriles, and aromatics, and these generally observe in the region of 170 to 205 nanometer range. The third one is when saturated compounds contains atoms with lone pair of electrons like oxygen, nitrogen, and sulfur, and halogens. These are capable of n sigma star transition, and these transition requires less energy than pi sigma sigma star transition. And most of the organic functional group lies under it, with from range 150 to 250 nanometer. Third type of transition is n pi star, when an electron from non-bonding orbital is promoted to antibonding pi star, and compounds containing double bond involving heteroatoms like CO, C, and NO undergo such type of transition under with maximum wavelength of 300 nanometer and minimum energy. And the fifth one is, these electronic transitions are forbidden generally, sigma to pi star and pi to sigma star. Thus electronic transitions, these are forbidden and theoretically possible only. Thus n pi star and pi star electronic transition shows absorption in a region above 200 nanometer, which is accessible to UV visible scope, and the UV spectrum is only a few baud of absorption. Another terminology here, we will use chromophore. The part of molecule responsible for imparting color are chromophores, and or you can say the functional group containing multiple bonds capable of observing radiation above 200 nanometer due to n pi star and pi star are called chromophores, like NO2, NO, C double bond O, C double bond N, C triple bond N, C double bond C, C double bond S. To interpret a UV visible spectra, following point should be noted: that non-conjugated alkene shows an intense absorption below 200 nanometer and therefore inaccessible to UV spectrophotometer. In same way, non-conjugated carbonyl group compound give weak absorption band in the 200 to 300 nanometer region. In chromoforms, like in acetone, has lambda maximum 279 nanometer, cyclohexane have 291 nanometer. Another type of functional group is there called oxocoms, which are attached to chromophore to modify the ability of chromophore to observe light, altering the wavelength or intensity of absorption. They are must for chromophore to show the visibility or in this UV visible region. The functional group, you can say, the function with non-bonding electrons that does not observe radiation in near UV region, but when attached to chromophore alters the wavelength and the intensity of absorption. Oxochromes like benzene lambda maximum 255 nanometer, phenol lambda maximum 270, and aniline having lambda maximum 280 nanometer. So, on the basis of these exochromes and different groups chromophores, there are different type of shifts in this UV spectrometer. So UV spectrometer, you can say, we are living in a UV visible region where photosynthesis is happening and different all of the life processes happening. So we can understand the importance of this region for our life, for everything. Thank you very much. We will study further in next lecture. Thank you very much. Have a nice day.